Now we're just going to do this general approach that we spent like the last 20 minutes working on for the generic problem. We're going to apply this approach to a specific problem. And it's still going to be a little bit long, but it'll hopefully feel less abstract when we have real functions you can plug in. And so that example is going to be to solve the differential equation x squared y double prime plus 2xy prime minus 6y equal to 0. And we're given y1 equal to x squared. And we're going to try to solve this differential equation. So, kind of our first step for this type of problem when we're given y1 is to say y2 is probably u times y1. And we're told right away that y1 is x squared, so we're saying that y2 is equal to some unknown u times x squared. Then y2 prime would be 2x times u plus u prime x squared. And y2 double prime would be 2 times u plus 2x u prime plus 2x u prime plus u double prime x squared. And I'm just going to highlight real quick that the first 2x u prime came from the product rule on the first term, and the second 2x u prime came from the product rule on the second term. The derivatives, I know, can get a little complicated when you're doing the double product rules. And when I simplify it, that just becomes a 4x u prime in the middle. My u double prime x squared is left over on the end. Now that I know what y2 is, and I've taken both of its derivatives, I can plug it into this ODE that we were given. So let's see, I've got 0 is equal to x squared y2 double prime plus 2x y2 prime minus 6y2. Kind of a quick aside, usually when we're given a form that we expect a differential equation in, we say that we have to clear whatever's on the y double prime. This is one where it doesn't matter. Kind of when we start to simplify everything, we'll end up rearranging when we get to solving a differential equation. But for now, it's okay. You could go ahead and divide through by x squared if you wanted to, though. I've got x squared times y2 double prime, so that's 2u plus 4x u prime plus u double prime x squared plus 2x y2 prime, so that's 2x u plus u prime x squared minus 6y2, and that's u times x squared. And this is the part where it can get a little bit complicated trying to simplify everything, because before it was really obvious what part belonged to y1, but now it's a little bit less obvious. But what we have is that the thing that goes away is always the lowest part right here. Remember, it was always attached to the u when we did that. Oops, I wanted to go back pages. Here we go. When we factored out the thing that goes away, it was all the terms that were attached to u. And that's not by accident. The reduction of order that we do only turns it into a first order because there's no u. We have u prime and u double prime. So even though we can't really see what's going to disappear, we can go ahead and factor it out, and we know that it will disappear in the end. So I'm going to go ahead and kind of take all my u terms right here. I've got 2x squared plus 4x squared, or 2x times 2x. Actually, I'll leave it in that term because it's a little easier to see. minus 6x squared. Right there. And then I'll go ahead and hold on to all my other terms. So I've got 4x, actually I'll multiply those out in the next step. 4x u prime plus u double prime x squared plus 2x times u prime x squared left over. And just to make it really obvious where these terms came from, they're right there, and right there. And then this term right here is going to go to 0. And we can even see that. Here's our y1 is x squared. Here's our y1 prime would be 2x. And then y1 double prime would just be 2. So we're looking at x squared y1 double prime plus 2x y1 prime minus 6y1. And we know that that equals 0. So that's our original ODE. Y1 was a solution to the ODE. That term goes away. And then what we're left with is these terms right here. I guess real quick, maybe it would be good to reassure you, if you didn't see that trick right there, here's another way that that term could go away. Actually, I don't want to delete it entirely, but we'll just do this step as if I hadn't seen that. That way it's, you don't worry that you have to always spot it. So 2x squared plus 2x times 2x minus, what was it, 6x squared. And then I've got my x squared 4x u prime plus u double prime x squared plus 2x u prime x squared. Okay, so if I hadn't spotted that, instead I could just sort of start working on the algebra and see what happens. So I've got 2x squared plus 4x squared minus 6x squared, which is 0. And so either way, that term goes away, whether you recognize it as the solution or not, and you're just left with everything else. So we've got 4x cubed u prime plus u double prime x to the 4th plus 2x cubed u prime. And that's 0 equal to 4 plus 2 is 6. So we've got u double prime x to the 4th plus 6x cubed u prime. And we could go ahead and factor out that common x cubed. We're just left with u double prime x plus 6u prime. And since it's equal to 0, we're just left with u double prime times x plus 6u prime. Oops, I zoomed in right there. Okay. So whether you recognize the little trick or not, if you follow through the algebra, it's always going to eventually take you to something really simple looking. And our next step is always going to be to say w is equal to u prime, which means u double prime is equal to w prime. And the ODE to solve is just 0 equal to w prime times x plus 6 times w, or x dw dx plus 6w. There's a little bit of freedom in this method because this is a linear equation or a separable equation, but I prefer separable equations, so I'm going to solve it as a separable equation. But we're right up at 10 minutes. These problems are really long, so I'm going to stop here, and then we'll carry out that integration and plug everything back in the next video.